Perfect. Okay. I will be screen sharing again. And I'll be introducing each of you guys before you get started. Okay, hold on. Why is this happening? Okay, perfect. Can you guys all see this okay? Awesome. All right. So we'll be getting started with our first presenter, who is Raghav Palapothu, who will be presenting on high-frequency oscillations in pediatric epilepsy, analyzing age and sex-related variations. Take it away whenever you're ready.
Hi, my name is Raghav Palapothu, and for this research program, I focus on high-frequency oscillations in pediatric epilepsy and how they differ with age and sex-related variations. So to give a little bit of background, epilepsy affects nearly 3 million American adults, with 56% of these people still reporting having one seizure each year. Now, new evidence has risen that supports that high-frequency oscillations can serve as a biomarker for predicting epilepsy. High-frequency oscillations are sort of brain waves that are exhibited in the limbic system of the brain, which are typically independent of epilepsy. However, new evidence has suggested that two types of HFOs known as ripples, which are between 80 and 250 hertz, and fast ripples from 250 to 600 hertz, are linked towards increased epilepsy risk. As a result, we decided to study the relationship between sex and age and ripple and fast ripple HFOs. So first, we collected a 30 pediatric children's sample from 0.8 to 17.4 years of age from an open neuro data repository. As seen in figure 1, that is the distribution of males and females we had in the study, a little bit more females. And in age, we had a little bit more people who were in younger than 7 than people older than 7. And as a result, we decided to conduct a t-test to see the observation of age changes and sex differences. Our procedure, first we performed a systematic literature review of 27 sources considering the relationship between neuronal excitability in different sexes. However, since this is not a widely studied idea, we did not see that many results from that literature review. As a result, we conducted an original research project as a pilot project in sex-related variations. We used EEG lab and available open neuro data to bipolar reference and pre-process the data to remove external stimuli, and we ran an MATLAB application known as HFO app to automatically detect HFOs and used manual detection to ensure that. After averaging the frequency, amplitude, and counting the amount, we put this into JASP and IBM SPSS to get a t-test of the comparison of means. In our results in figure 2, you can see that those are the areas of the brain that we found were most affected by epileptic HFOs. We found that the hippocampus, the amygdala, and the thalamus are the areas where we saw the most abnormal form of brain activity during HFOs. In figure 3, you can see that gender and age in the top 2 rows had a strongly negative correlation with HFO exhibition. As you can see, with people who were having a higher age typically had lower amount of HFOs. However, that contradictory result also occurred with fast ripples, where age was seen to actually have an increase in the amount of HFOs later on. After comparing the t-test of means, we actually then found that people above the age of 7 exhibited more HFOs than people below the age of 7, and males, in fact, exhibited more neuronal excitability than females. After conducting an F-test for variance, we revealed significant differences in the variance of frequency between males and females and fast ripple HFOs, implying a difference in the structure of the limbic system between males and females. Similarly, males tend to exhibit a higher amygdala volume, which influences their exhibition of HFOs. Although the results we acquired did not necessarily reveal significance, there may be a trend between the amount of ripple HFOs and differing sex status, implying that males experience more neuronal excitability than females. And as a second test that did not directly reveal significance, the relationship between age and the frequency of ripple HFOs may indicate a trend, suggesting a trend in the neural excitability of older ages, which is contradictory to current results, which suggests that people of younger ages have more neuronal excitability, but also goes along with some current research that suggests that through puberty, we tend to exhibit more neuronal excitability than previously before. And as conclusions, we found that in future directions, we need to replicate the study with much larger data sets. Through long-term longitudinal studies can further kind of isolate those differing characteristics of HFOs, amount, frequency, and amplitude that occur during changes in age and sex. In addition, using HFO app which is in figure 5, as you can see, that app that analyzes 3 different EEGs at one time, and in blue highlights the abnormal brain activity. We can develop linear regression machine learning models to further predict the onset of epileptic seizures from HFO amplitudes, frequency, and amounts that's adjustable to age and sex, which can be useful to predict the onset of epilepsy. In addition, using tools like HFO app, we can develop real-time HFO detection systems to aid in intraoperative monitoring and immediate clinical decision-making. Exploring the role of HFOs is extremely large in the epileptic industry right now, as it can aid in neurostimulation therapies as well, and RNS and deep brain stimulation for epilepsy and other neurological disorders. As this is a currently rising topic in the Epileptic Journal, this is extremely interesting and extremely crucial towards us to study in HFOs in the future. Thank you and have a great day.
Awesome. Quick round of applause. Thank you so much, Raghav. That was awesome. All right, so next up, we will be moving on to Vishesh Sood, who will be presenting on exploring the importance of transcription by RNA polymerase II and its therapeutic targeting in cancer. Feel free to start whenever you're ready. Is Vishesh here? Okay, I don't see him in the room, so we will move on to the next presentation for now, which will be coming from Rian de los Santos on micromediation for wildfires, integrating current bioremediation methods with remote sensing technology. 5 minutes starts whenever you're ready.
Hello, my name is Rian de los Santos, and my research is micromediation for wildfires, integrating current bioremediation methods with remote sensing technology. Wildfires have occurred frequently and have risen in frequencies of up to 150% since the 1970s. This has resulted in degrading ecosystems, especially in the Western United States, due to its semi-arid climate. This can create degrading ecosystems that degrade both socially in people's homes, environmentally with plants in the ecosystem, and also health-wise with degrading air qualities and affecting people's health as well. With this, restoration efforts are often costly, causing environmental stress on the government, which can lead to lots of money being put into this. So researchers have looked for other methods of remediation for this. Specifically, bioremediation, the use of natural occurring microorganisms or plants, has been used to remediate these efforts, especially in polluted areas. Specifically, microremediation, which is the use of fungi for remediation, has been utilized in wildfires due to its resilience in high stress and high heat conditions. This has been optimal for research in fungi remediation, making it optimal for wildfires as it can remediate using mycelium, which is similar to plant roots, which deploys enzymes in the soil, and these enzymes can then extract the toxins that are in the soil, putting this out as organic material into the environment and providing ecological balance for the environment. Leading to the research question of how can remote sensing technologies be employed to enhance the effectiveness and efficiency of microremediation in restoring post-wildfire ecosystems. So for my methods, I conducted a systematic review with an identification process of first identifying the title and keywords of the article, then the inclusion exclusion criteria, as well as the title, abstract, and full article screening to see its relation to my research question and topic. And then the studies included were also examined. The most prominent keywords that were in this were the cause and effects of wildfires, specifically in the Western United States, AMF properties, as well as mycorrhizal fungi remediation and remote sensing technologies. So in figure 1, in the figure above, this shows a flowchart methodology of the process that I use, starting with the more broader 4 topics of wildfires with its evolution and causes and effects in these environments, as well as specifically wildfires in the Western United States, since wildfires in the Western United States are more prominent in states such as California and Oregon, with wildfires occurring up to 55,000 in 2023. As well as post-fire remediation with its current efforts, concerns, and bioremediation specifically, and remote sensing technologies, which are often used in these post-wildfire or polluted areas for monitoring, and these implementations and restoration efforts in this. This was then narrowed down to bioremediation specifically, as it causes minimal ecological disruption compared with current remediation efforts, which take a lot of human labor from firefighters, construction workers, and considerably plow the land, which disrupts the ecological concerns in this area. And specifically onto microremediation in this area, as this is more optimal for post-wildfire restoration, as fungi can form symbiotic relationships with the other plants, forming that resilience that is needed in these polluted areas, as well as airborne remote sensing specifically, this is more concise and can be better for landscape levels as where the forest or ecosystem that this is occurring in. And as a result of this, I identified the causes of the wildfires to be human activity and urbanization, specifically with human activity of wildfires that are left out, and this can turn into larger uncontrollable fires, as well as the effective fires, which are environmental, economical, and social. As mentioned before, the environmental are currently chemicals that are used in restoration efforts, and also CO2 that is released, contributing to the greenhouse gas effect, and as well as the economic concerns of the restoration costs and hospital costs as well, due to degrading air quality. And this can also play into microremediation, specifically arbuscular mycorrhizal fungi, which is a type of fungi that is used in wildfires, as it's resilient in high heat conditions and more optimal in this area as well. For remote sensing technologies, these are usually used for monitoring. So as I found in my literature, this is also very optimal with its cost effectiveness and concise for landscape level analysis. So onto my conclusions and future implementations, I chose to use AMF, which is arbuscular mycorrhizal fungi, for microremediation. As compared with other types of fungi, this forms symbiotic relationships with plants, meaning that while it extracts the toxins from plants, this forms symbiotic relationships that build the resilience of the plants that are still in that ecosystem, providing growth and reducing the variabilities that can cause vulnerabilities to more fires to occur in the future, coupled with drone-based LiDAR technology, as drones are more cost-effective than other aircrafts, and this can be used for monitoring of the soil properties and vegetation, as well as enhancing the overall process. These are my references. Thank you.
So thank you so much. Another round of applause. Great job. All right, so next up we have Sahaj Satani presenting on a review of classical and novel shape memory materials for biomedical applications. Whenever you're ready, Sahaj.
Hello, today I'll be talking about shape memory materials, also known as SMMs, and they're basically fascinating, or they have a fascinating ability to return to their original shape after being deformed. So basically they change shape in response to specific stimuli such as temperature or mechanical stress by undergoing a phase transition. Then they revert back to the original shape when the stimulus is removed or reversed, typically through a change in temperature or environmental conditions. You can see this in Figure 1 as provided. Regarding my motivation, shape memory materials have been used in biomedical applications throughout the human body for a long time, as shown in Figure 2. Nickel titanium alloys, also known as nitride alloys, for example, are an example of a shape memory material that have been used for a very long time. And this is due to their excellent compatibility and mechanical properties. However, challenges like nickel toxicity and high costs made us investigate other alternatives. By exploring other materials such as zirconia ceramics and copper-based alloys, we can aim to expand and improvise our use of shape memory materials in the medical field. To do this, we conducted a thorough current research review to compare 3 different types of shape memory materials: nitride alloys, zirconia ceramics, and copper-based alloys. We assessed their performance based on biocompatibility, mechanical properties, wear resistance, corrosion resistance, and thermal stability. To create the figures and correctly make the figures, we use Python's matplotlib and NumPy sources. Now, moving on to the material comparisons. The top image shows biocompatibility. Zirconia ceramics lead with the superior safety and suitability for long term. Nitride alloys, on the other hand, are good, but they can release nickel ions, as I mentioned earlier, which can be quite a big concern. And then copper-based shape memory alloys have the lowest biocompatibility due to the potential copper ion toxicity, but can be improved through other treatments as well, which I'll talk about later in the future work section. The middle image shows wear rates. Zirconia ceramics excel in wear resistance, making them ideal for applications where durability is key. Nitide alloys, on the other hand, have moderate wear resistance, including copper-based alloys, which can both be enhanced through surface treatments, which more can be talked in the future work section. The bottom image shows mechanical properties, including ultimate tensile strength, Young's modulus, and elongation at break. Nitide alloys are the most flexible, which is beneficial for devices requiring deformation and recovery. Zirconia ceramics are very stiff, suitable for structural applications, while copper-based SMAs offer a balance of flexibility and strength. We studied corrosion rates and thermal stability as well. However, we thought that the other features that we discussed earlier were much more important in our field of making conclusions. Moving on to the analysis, so by evaluating these different properties, we identified which materials are best suited for which biomedical applications, helping us guide future medical or material choices for devices like stents, implants, and other medical tools. So combining all of this data, we came to the conclusion that nitide alloys are excellent for applications requiring flexibility and biocompatibility, like stents and dental implants. Their shape memory effect and corrosion resistance are ideal for invasive and flexible devices. Zirconia ceramics are ideal for applications needing strength and flexibility, such as bone and dental implants. Their superior hardness and chemical stability also provide to their durability, making them suitable for load-bearing and high-strength applications. Copper-based alloys provide a versatile option with potential improvements for specific uses, like joint replacements and bone implants, and they also offer an alternative where nickel biocompatibility is a big concern, which can also enhance performance through surface treatments. We aim to optimize copper-based SMAs for better mechanical properties and biocompatibility, and also enhance zirconia ceramics flexibility and develop advanced coating for nitide alloys to improve performance. We are not only looking to refine these materials, but to push the boundaries of what shape memory materials can achieve in biomedical fields in the future, aiming for breakthroughs that could revolutionize patient care and device performance in the near future or long-term future as well. Overall, I'd like to thank the entire Harvard Open Bio team and my mentor, Eliana, for their tremendous support. And thank you all for your attention. And I'm also happy to answer any questions through Slack DMs. Thank you.
Awesome. Great job. Thank you so much, Sahaj. Cool. Okay, next up we have Sarah Yusufu, who will be presenting a study on cyanobacteria in the presence of space radiation and their applications to a Martian BLSS. Whenever you're ready, Sarah.
Thank you. Since the beginning of time, humans have often wondered about their place in the universe. One of the ways we seek to understand more about humanity's past, present, and future is by exploring other celestial bodies. One body that has caught the attention of many organizations across the globe is Mars. However, in order to settle on Mars, the lethal effects of radiation must be mitigated. Radiation, including galactic cosmic radiation and ultraviolet radiation, can cause the formation of free radicals in not only humans, but plants as well. These free radicals induce macromolecule damage, including genetic damage. These effects can be tumor-forming and lead to the loss of homeostasis. While organisms on Earth are exposed to radiation, the effects of radiation are much more prominent on the surface of Mars due to its lack of a thick atmosphere and strong magnetosphere. As a matter of fact, the effective radiation dose on Mars in 1 year significantly exceeds the occupational and civilian dose recommended by the International Commission on Radiological Protection. Therefore, it is important to create systems that mimic the Earth's ability to recycle resources and provide radiation protection. These systems are called Bioregenerative Life Support System, or BLSS. In other words, the BLSS is an artificial ecosystem. Multiple studies have been conducted into the possibilities of incorporating cyanobacteria into BLSS as a protection against radiation. Various studies found that cyanobacteria can form aromatic compounds such as phycocyanins and phycobiloproteins, that have antioxidant and anti-inflammatory properties. Antioxidants can be supplemented into the diets of astronauts to help prevent aging, as well as prevent free radicals from causing too much cellular damage. Some of these compounds can also be used as a sunscreen for both humans and plants. In addition, cyanobacteria are autotrophs, recycling carbon dioxide and converting it into breathable oxygen. So, not only can cyanobacteria help recycle and produce necessary compounds, they can also be used to help protect another type of autotroph, higher plants. There are many avenues that future research should focus on improving. For example, due to there being a variety of cyanobacteria present on Earth, future studies should focus on profiling these various types of cyanobacteria. This is important because some may be more radiation resistant, form more antioxidants, or produce less cyanotoxins. Depending on what types of negative effects of space travel must be mitigated, certain cyanobacteria should be taken along on the journey. In addition, AlphaFold and other AI technologies can investigate the possibilities of engineering new compounds that contain the aromatic structures that absorb UV radiation. Perhaps cyanobacteria can be genetically modified to produce these new molecules. Future studies should also determine the most effective method of incorporating compounds produced by cyanobacteria into the BLSS. In other words, should it only be used for diet supplementation, sunscreening abilities, or integration to building materials? Can there be other methods of application? In the end, integrating cyanobacteria into BLSS is an important step in the direction of long-term Martian settlement because it can help prevent the negative effects of free radicals caused by radiation. They will ultimately allow us to become an interplanetary species and explore Mars. Cyanobacteria are small creatures, but when used in a creative and scientific manner, they hold the key to understanding the largest thing in the world, the universe. Thank you.
Awesome. Thank you so much. Perfect. So we are happy to be joined by Vishesh. So we'll be heading back to his presentation before we continue along with the rest of the schedule. So Vishesh, if you're ready, I'm going to head back to your slides. And just give me a thumbs up if you're good. Okay, awesome. So today we'll be hearing from Vishesh Sood, who will be presenting on exploring the importance of transcription by RNA polymerase II and its therapeutic targeting in cancer, whenever you're ready.
Hi, my name is Vishesh Sood, and today I'll be talking to you about how transcription, what it is, and how it can be used in targeting cancer and preventing it from growth. So some basic information. Transcription is the process of turning DNA into RNA. This is generally caused by one protein complex known as RNA polymerase II. This RNA polymerase II is controlled by another protein known as PTEF-B. PTEF-B is a phosphorylator, which basically, to liken RNA polymerase to a car, it's basically the gas that makes the car go down the gene and do the process of transcription. So this PTEF-B is recruited by another protein, also known as BRD4. BRD4 is a BET protein and is basically recruits PTEF-B to the RNA polymerase to again make the car go. So my project is about how you can look into that BRD4 and see, oh, if I can prevent that BRD4 from recruiting that PTEF-B, that transcription can be stopped. So a little bit more background information. In cancer, cancer is addicted to transcription. It is needed to mature the cell, to keep it growing, and to prevent it from cell death. So basically, if you can prevent that BRD4 from recruiting that PTEF-B, you can basically stop any transcription, and which slows down the growth of cancer and eventually completely stops it. Okay, then let's continue talking. Let's continue talking about some other things. So there is another thing called MYC, which is an oncogene, which basically controls the transcription, which is another factor of transcription, which again regulates cell maturation, cell growth, and during cancer, cancer uses this MYC and it'll express MYC, which basically causes more cell growth, more cancer growth. So again, so this is all linked to the BRD4. So if we can prevent this BRD4 from recruiting this PTFB, we can prevent all of this growth. So then let's move on to the results of my literature review. So when I was looking into the different papers, they all talked about the different types of regulators and how to prevent prevent this. But today we're specifically focusing on BET proteins. An example of a BET inhibitor would be JQ1. JQ1 is a promising treatment in MYC-driven cancers. And basically, again, preventing this MYC and can help completely stop cancer. And
Okay.
You're good. It was just some background noise. Feel free to go.
Oh, sorry. So JQ1 is an example of these BET inhibitors, is an example of a BET inhibitor, and will prevent this BRD4 from connecting. So if you look down to the first figure on the bottom, this is the beginning process of transcription. So there's RNA pool 2, the PTFB being recruited, the RNA going down the gene, and basically creating the RNA polymerase creating the RNA. So the way I did this was through two major databases. One was the CBio portal, which contains genomic data from thousands of tumor patients across various cancer types. But I specifically focused on myeloid cancers, which are more commonly known as blood cancers. Another one was DepMap. DepMap is a research database that helps researchers identify genes that are crucial in specific contexts. So how JQ1 affects these MYC expression. So the second figure on the right side is an example of how of JQ1 and MYC expression across 3 different cancers: lung, lymphoid, and myeloid. But in conclusion, transcription is a process essential to maintain homeostasis, and cancer overexpresses all this transcription and causes it to go haywire. And if we can prevent transcription from being overused during cancer, we can eventually slow and stop cancer growth, therefore giving the patient more time to have more treatments. So I would also like to give a special thanks for my time ends. I would like to thank the SRI program for giving me this chance, and I'd like to thank my mentor Nicola for teaching me everything about this and helping me throughout this process of this. Thank you.
Awesome. Thank you so much, Vishesh. Great. We will be moving on to our next presentation from Serena Kabuhat, who will be presenting on acute lymphoblastic leukemia, a holistic review of genetic and environmental contributors in adult and pediatric patients. Okay, 5 minutes whenever you're ready, Serena.
Good afternoon, judges, peers, and families. My name is Serena Kabuat, and I am a student from California attending Sato Academy of Math and Science and one of the mentees from the 2024 Harvard Student Research Institute. I worked alongside my mentor, Lily Spire, who is a biomedical engineering PhD student at Case Western Reserve University, to produce a literature review discussing the genetic and environmental contributors to acute lymphoblastic leukemia, also shortened to ALL. But now, what is ALL? Raise your hand if you or someone you know has been impacted by cancer. I have also been impacted, as I was actually diagnosed with ALL at 10 years old and have been free since 2020, which is why I chose ALL as my research topic. ALL is a type of acute leukemia that is characterized by various chromosomal and genetic mutations, which influences its subtypes. These subtypes fall into two main forms, BALO and TALO, where B or T lymphoid stem cells proliferate at abnormal rates. These immature stem cells take up space and limit the growth of essential bone marrow components. Symptomatically, this can result in swollen lymph nodes, petechiae, drowsiness, and more. Children, specifically those between 2 and 5, and adults over 40, are most likely to develop this disease. Although both populations have high incidence rates, children tend to have more favorable outcomes compared to adults, with children having 80 to 85% of 5-year event-free survival and adults having less than 50% of 3-year event-free survival. The outcomes and likelihood of developing ALL tie into the patient's genetics, epigenetics, and external risk factors that could increase their chances of having ALL, which will be gone over in the presentation. One of the main factors associated with ALL are the individual's genetics. B-cell ALL makes up over 80% of diagnoses, meaning there is more research done for this type. Using data from D'Angelo et al., the graph shown represents the likelihood of BALL patients having various genetic mutations and compares the likelihood between adults, represented by the blue, and pediatrics, represented by the red. From the peaks, you can see that pediatric patients tended to have alterations with more favorable outcomes, such as hyperdiploidy and translocations in chromosomes 12 and 21, while adults tend to have mutations with more dismal prognoses, such as Philadelphia chromosome-like alterations. Those diagnosed with TALL also tend to face dismal results, but one of the most common gene alterations is in the NOTCH1 gene and is present in over 50% of pediatric TALLs. Another major role in increasing of ALL incidences is epigenetics. Epigenetics ties into cell division and RNA sequencing. Common modifications for ALL can include methylation and histone modifications, where they influence the expression of certain genes by blocking off certain sections of the DNA sequence. Mutations in the genes that are epigenetic regulators tend to silence tumor suppressor genes or activate the oncogenes, which allows for the cancer to develop. For B-cell ALL and Down syndrome patients, a frequent example is hypermethylation in the RUNX1 gene. For those who have early thymic precursor to ALL, there are also normally mutations in genes that help with DNA methylation. Lastly, there are a range of risk factors associated with higher risk of developing ALL. Aside from age previously mentioned, females tend to have higher rates during their first year of life, while males have higher rates overall. Regarding race, for studies done in the US, ALL tends to be more prevalent with white and Hispanic populations, but Hispanic and African American populations tend to face about 40 to 45% higher rates of mortality compared to the white population. For external factors, it is mainly based on what the individual is exposed to first or secondhand, such as cancer-causing agents. These can include infections, viruses, fungi, ionizing radiation, chemicals such as benzene, pesticides, etc., smoking, or even marijuana usage. Despite them being a multitude of factors associated with high risk of ALL, the malignancy's etiology has yet to be completely understood. However, as we continue to make strides into discovering the risk factors on a molecular and larger scales, it is important to continue pursuing ALL research as cases continue to rise. With less intensive treatments, adults have also begun to have higher rates of survival, like their pediatric counterparts. Further research into the overall ALL genomic landscape will allow for certain minority groups, adolescents, and young adults to have specialized care and increased efficacy. I would like to thank the Open Bio team and Harvard professors for giving me such an incredible opportunity, my family and friends for supporting me through the thick and thin, and most importantly, my mentor, Lily, for dealing with my constant schedule changes, questions, and allowing for us to complete this with limited time. Thank you so much for this opportunity and have a wonderful day.
Awesome. Thank you so much, Serena. Great job. Cool. Okay, up next, we have Shorya Shakvani, who will be presenting on the role of high sugar diets in modulating the gut microbiome and accelerating the development of Alzheimer's disease. Shorya, whenever you're ready, you have 5 minutes. I think Shorya is frozen, so we'll give that a minute.
Can you hear me? Hello?
Yes, we can hear you now. You're all
Sorry, it seems like my Wi-Fi cut out as soon as you said my name.
all good. No worries. Whenever you're ready.
Okay. Hey, let's get started. So right here, I have a can of soda, and it tastes amazing. So let me just take a quick sip. And I can tell you, and I assure you, it is amazing. But this soda isn't good for me. Why is that? A lot of people say that, and that exceeds the recommended daily amount of sugar that is allowed by the American Heart Association. Sure, sugar is bad for you, right? But how is that? And I want to know so much more. So I did my research project on how high sugar diets affect bacteria such as Enterobacter and Clostridium while suppressing the growth of beneficial bacteria like Lactobacillus and Bifidobacterium. Well, these harmful bacteria thrive on sugar and can outcompete the good bacteria, disrupting the balance of your gut microbiome. This is also known as dysbiosis. These harmful bacteria produce substances like lipopolysaccharides or LPS. LPS are large molecules found in the outer membrane of certain bacteria and are potent inflammatory agents. The overgrowth of harmful bacteria and the production of LPS can damage the gut lining, making it way more permeable. This is often referred to as leaky gut. When the gut lining is compromised, there are harmful substances that can enter the bloodstream. Once in the bloodstream, LPS and other inflammatory substances can then travel throughout your whole body, triggering systemic inflammation. This systemic inflammation can reach the brain, leading to neuroinflammation. And neuroinflammation is a key to my entire research project. But let's hold on and wait a minute. We'll come back to that. The blood-brain barrier is a selective barrier that protects the brain from harmful substances like blood. However, chronic systematic inflammation can make this barrier more permeable as well, allowing for LPS and other inflammatory agents to enter your brain. When these inflammatory agents reach the brain, they can diseases like Alzheimer's disease. It can exacerbate the production and process of amyloid beta plaques, which are a key characteristic of Alzheimer's disease. And these can also further damage neurons, leading to your overall You can clearly see the correlation between a high sugar diet and the amount of amyloid beta plaques. To combat these negative effects reduce the production of harmful substances like LPS, and strengthen the gut-brain barrier, preventing the onset of systemic inflammation and neuroinflammation. So I do want to drink this Coke every single day, or this sugary drink. But why shouldn't I do it? Well, there's multiple. Hello, can you guys hear me? I don't know what just happened, but it just kicked me out and it put me back in.
Yeah, we can hear you now. Feel free to continue.
Okay, do you know where I left off? Because I'm not sure where,
Yeah,
um,
I think maybe just start at like the second to last point that you were making. I think
okay,
you're cutting off.
okay, all right. So to combat the negative effects of high sugar diets, dietary interventions such as prebiotics and probiotics can be beneficial. Prebiotics are non-digestible food components that promote the growth of beneficial bacteria in your gut. As mentioned before, these can help you in your overall well-being. And I do want to drink this Coke, as I was mentioning before I probably cut out, and I want to drink it every single day. But what is stopping me, right? Who is stopping me from going to the store, grabbing this can of soda and just taking it, right? So we really need to focus on how our diets in the whole world are being altered by not only specific components of sugary drinks, but sugary foods in general. If I go to the store right now, I can go grab myself a nice, delicious cheesecake and enjoy the rest of my day. But I can't because I know it's bad for me. When it comes to having the development of Alzheimer's disease, it's important to make sure you understand how Alzheimer's is developed. And of course, neuroinflammation is one of the main issues. And ultimately there are other causes to the development of neuroinflammation, some of which can be just a bad diet in general, as well as some of which can be just other things that haven't been researched yet. So when it comes to defining how Alzheimer's disease is developed, make sure you look at the gut microbiome and how it can help accelerate the development of AD. So that is my presentation. If you can see right now, if you look on my slide, there is two sources that I have used. I use PubMed and Google Scholar. These help me narrow down specific and very, very productive literature reviews that help define specific examples on how AD is either developed or on how a high sugar diet can affect your gut microbiome. The gut microbiome needs to be studied more, as the gut microbiome has been shown to have other links throughout your entire body. When it comes to finding specific research, there were many specific criteria that I have used. One of which was that you should make sure that each specific literature review is best determined to a specific age group. Thank you.
Thank you, Shurya. Awesome, great job. Next, we'll be moving on to Sophia Yang, who will be presenting on the opioid epidemic among older adults, risk factors, impacts, and treatment strategies. Sophia, 5 minutes whenever you're ready.
All right, so before I begin, I want to give a big thanks to OpenBio and the SRI organizers for running this whole program. These past 2 months have been an amazing experience for me, and I'm sure for everyone else here. And so, as you heard, my name is Sophia Yang, and I'm super excited to be able to present to you all today my research regarding the opioid misuse and addiction among older adults. So in the past 10 years, opioid use disorder has become a national health crisis, with over 80,000 opioid-related overdose deaths in the US in 2022 alone. Unfortunately, older adults are one of the populations most at risk to problematic opioid misuse for many reasons, which I'll elaborate on below. Despite its increasing prevalence, research related to opioid addiction in older adults is lacking. Lots of studies omit older adults from their experimental groups, which results in the treatment of opioid addiction for them to be done similar to their younger counterparts. However, the bodies of the elderly are very different from younger or middle-aged adults and require unique treatment methods. So with this literature review, I wanted to take a deep dive into understanding opioid misuse in older adults, and I wanted to collect all of the most recent studies related to risk factors, negative impacts, and the best models of treatment, and then compile it all into one concise paper. So before beginning my initial research, I used the PICO framework to identify the key concepts of my topic and to actually structure my literature review. And so the PICO framework is an acronym that stands for population, intervention, comparison, and outcome. And each of these components correspond to an essential aspect of my research that I wanted to address. And so when I actually began my literature review, I made sure to only use studies conducted after 2018, and I did searches off of PubMed and Google Scholar. And so I'm going to provide a general summary of all of my results. So first up, risk factors for opioid addiction in older adults. These include chronic pain, mental health issues, and general aging, and I'll touch up on a few of these key points. So you might be wondering why chronic pain is on here, but in case you didn't know, 40% of older adults deal with some sort of chronic pain. And because most of them are regularly using pain medication, they have an increased access to opioids, and so their risk of misuse is higher. Lower education or low income exacerbates the risk of misuse in these situations. Moreover, aging. As people age, medication affects them more strongly.
opioids linger in their system for longer, which increases the negative effects of opioids. And regarding impacts, opioid addiction in older adults is very dangerous, and there are often a lot of negative effects that accompany it, which can eventually lead to death. These include reduced gray matter, which is crucial for basic cognitive functions in decision-making, general cognitive impairment, falls, and mood changes. For example, in a study compared to those not on opioids, a study discovered that individuals exposed to opioids scored significantly lower on the mini mental state examination, MMSE, which is kind of used to test the mental state of patients. And as noted earlier regarding falls, the increased risk of falls is important because falls are the leading cause of injury death in older adults. And so, of course, we want to reduce the chances of falls in these individuals as much as possible. And another thing, unfortunately, many older adults are discouraged from seeking medical care because of the stigma associated with drug use. And this is something that needs to be changed. Lastly, not much is known about exact treatment plans since it's really based on a person-to-person basis. It's not one like shoe fits all, right? But generally, buprenorphine is recommended as a first-line treatment paired with non-pharmacological treatments, and these are treatments that don't involve drugs, such as various therapies. But of course, generally, caution must always be exercised. As I said earlier, despite how prevalent opioid misuse is among older adults, there's a lack of research focusing specifically on this demographic. And now, before I end it up here, I know this topic may seem far in the future for a lot of people, since from what it looks like, most people here are teenagers and adults, are not really in the age range where they have to worry about these types of health concerns. And even if you don't have parents or grandparents who face risk to this right now, this could obviously, hoping it doesn't, become a concern for them down the line in 10, 20, 30 years from now, and of course, in the future for us. So thank you for listening. I hope this has given you a glimpse into my research about opioid addiction in older adults really matters. Have an amazing day.
Thank you so much, Sophia. Round of applause. Great job. All right, we'll move on to Taylor Silla, who will be presenting on the benefits of probiotics on athletic performance in athletes. Taylor, 5 minutes starts whenever you're ready.
Hi, everyone. My name is Taylor, and I go to Independence High School in Independence, Wisconsin. I am very interested in athletes and sports, and I am even more interested in how our diet can affect that. So along with my mentor, Margarita Valdiviso, we decided to conduct a systematic review about probiotics and their benefit on athletic performance in athletes. To get a general review about what probiotics are, they were defined in 2014 by the Scientific Association for Probiotics and Prebiotics as live microorganisms which, when administered in an adequate amount, confer health benefits on the host. Before that even, they were discovered by Roman historian Planino in 4000 BC for having beneficial effects on gastrointestinal symptoms in the French people. Right now, however, they are super popular on social media platforms like TikTok and Instagram, and even more popular in the health market, which makes it kind of hard for everyone to understand what they actually do for your body. So this review's purpose is to narrow the scope of research on probiotics by looking specifically at athletes and how probiotics can help them in their performance. To do this, I use the Prisma diagram using identification and screening processes. I used PubMed, EBSCOhost, and ScienceDirect, and used the same keywords in each search in order to find accurate and similar results. I ended up with 242 articles. 11 were duplicates, and then overall came with 25 after all the inclusion criteria was used. So with that, all of the 25 studies showed 7 beneficial ways that probiotics can help your body. I'm going to go through these quick and help you kind of realize what they all do for your body. So first, they decrease GI symptoms. This makes athletes more comfortable and train harder so that they don't have stomach issues while they're trying to perform their best. Then there's neuro. They help with your brain. They increase the theta and beta waves in your brain to make you more attentive and more concentrated while you are performing. Your immune system, they strengthen your immune system, and you end up not getting as sick, and you can keep training, keep performing without being distracted by sick days. They help with nutrient absorption, helping your body to more efficiently use protein and carbs and iron in order to really get oxygen throughout your body, protein to build your muscles, and carbs to fuel throughout your practices. They help with anaerobic capacity. The more anaerobic capacity you have, the longer you can breathe and power through performances. They help aid recovery so that you can reach your full potential, being fresh and spick and span when you are playing on the field or running or whatever you're doing. And then they also help increase muscle strength, which kind of goes for explaining itself. The more muscle you have, the better you can perform. All in all, these studies show that probiotics can really help your athletic performance. However, there was limitation between all the studies in which they only conducted research on one gender. This is bad because each gender both have differences in their body mechanics, which can outcome in bad results. Seeing this, however, all we need is some future research that includes both genders as study people. Other than that, I want to thank everyone for listening. I want to thank the SRI committee, and I want to thank my mentor for helping me through this amazing project. Thank you, everybody.
Great job, Taylor. Thank you so much. Cool. Okay, so we'll be moving on to presentation from Toby Chen, who will be presenting on hydroxyapatite coatings for tissue engineering with an electroconvection perspective. Excuse me. Toby, whenever you're ready.
Yeah, thank you. First of all, I want to congratulate the presenters before me. Your works were very amazing and inspiring. For mine, I looked into studies that used electrodeposition as a means of coating hydroxyapatite onto scaffolds. Scaffolds are implants used in tissue engineering with the aim of replacing and repairing damaged tissues. There are many bone-related problems, such as osteonecrosis, that can be benefited from these implants. However, many scaffolds lack biocompatibility as their metallic ions can be corroded, causing them to dissolute into the surroundings, leading to inflammations and even cell death. Hydroxyapatite is composed of largely calcium and phosphate ions, which mimics the bone's natural composition. Thus, coating bare metal scaffolds such as stainless steel, nitinol, and titanium with hydroxyapatite can promote a better environment for cell growth and proliferation. An economically viable and efficient process to achieve this is through electrodeposition. As shown in figure 1 in the bottom left corner, passing an electric current between the two electrodes can cause the movement of calcium ions followed by phosphate ions to the working electrode, which is the scaffold, leading to the deposition and formation of the coating on the scaffold surface. As shown in figure 2, I manually screened 200 papers and ultimately included 11 studies in this literature review. This review focuses on current advancements in electrode deposition usage in coating stainless steel, nitinol, and titanium scaffolds with hydroxyapatite or hydroxyapatite incorporated composite materials. The result tables shown in the middle were organized by these 3 types of scaffolds. These 3 scaffolds were selected for their promising mechanical and structural properties. The tables collected data on notable techniques such as annealing, in vivo and in vitro assays, electrodeposition parameters, and major findings were also included. Most studies reported hydroxyapatite's efficacy in enhancing biocompatibility and decreasing corrosion rates. Incorporation of new materials often resulted in multifunctioning coatings that could be promising for future implementation. Highlighted in green were the studies that performed biological investigations, such as protein denaturation studies, cell viability assays, or in vivo evaluations. These techniques help us understand the coated scaffolds behaviors under physiological environments better. The rest inferred biocompatibility from corrosion rates studies. Most studies in the future can be benefited from in vitro and even in vivo testing to directly assess the effects of the coated scaffold. Highlighted in teal are studies that treated the scaffolds with high temperature for better annealing purposes. Highlighted in yellow are anodic oxidation techniques used by some studies to modify the surface of the scaffolds before electrodeposition for aims such as enhancing hydroxyapatite adhesion. Based on figure 3, only 3 out of 11 papers employed pre-electrodeposition surface modification to facilitate better adhesion of hydroxyapatite in the deposition process. Thus, future explorations into options for pre-electrodeposition treatments can be beneficial and may offer promising solutions that doesn't require the addition of other materials such as chitosan for better adhesion. 9 out of 11 studies used multifunctional hydroxyapatite composite coatings, incorporating materials such as carbon nanotubes, graphene oxide, and chitosan. These multifunctional hydroxyapatite coating combated pure hydroxyapatite coatings downsides, such as weakness in substrate adhesion, brittleness, weakness in osteointegration, and lack of antibacterial properties. Such incorporations of new materials were largely successful, and the multiple properties seem to be additive in rough terms. In addition to investigations in coating properties, a few studies also had a focus on how electrodeposition parameters such as pH, solvent type, and voltage changes morphology, as well as corrosion rates. These studies are valuable because they provide insights to optimizing coating properties without modifying its chemical composition by adding new materials. This marked a contrast with investigations aiming to solve the issue with multifunctional coatings or pre-electrodeposition treatments. Future studies can investigate other parameters such as temperature and electrolyte concentration. Since only 2 studies reported post-electrodeposition modifications, the field may also be benefited from more exploration in this direction. Perspectives from the field of electroconvective instability can also be brought in for gaining insights on more controlled coating environments. Instability during electrodeposition leads to poor quality of coating and the formation of dendrites. Detection of and discussion on electroconvective instability that occurs during the electrodeposition process were largely absent. It may be beneficial to record data in the form of current versus voltage graph, which will provide insights into the onset of the instability. This interdisciplinary approach may lead to a better and more controlled production of hydroxyapatite coatings in the future. Lastly, I just want to thank Arvil for helping me in this process. Thank you so much. And thanks everyone for listening. Yeah.
Awesome. Thank you so much, Toby. Great job. We will now be moving on to Tracy Chen, who will be presenting on the analysis of demographical bias in imputed lung cancer clinical data. Whenever you're ready, Tracy, your 5 minutes starts.
Thank you for the introduction. So for some context on my research, lung cancer is the single leading cause of cancer deaths and also the most common cancer type worldwide, taking 1.8 million lives every single year. In the US, the combined quantity of racial minorities diagnosed with lung cancer is significantly larger than their white counterparts. However, public data sets researchers themselves use are heavily skewed towards the white demographic, leading to disproportionate data gaps and underrepresentation of racial minorities. In the case of lung cancer, we see that minority groups are generally less likely to be diagnosed early, receive any treatment, and have approximately 20 to 30% higher chances of experiencing a misdiagnosis. With the difficulty of early detection and low survival rates, every chance for treating lung cancer is critical to patients. One step to filling in these data gaps is imputation, where imputation values or where missing values can be substituted with a calculated inference based on existing known values. But as you may know, biased input usually yields biased outputs. And though this has been a rising issue with AI, we did not find much literature on racial bias analysis for imputation, especially for lung cancer data. And thus, our research dives into a computational analysis on research disparities in imputed lung cancer data to evaluate the issues and potential remedies. So for this experiment, we collected the clinical data of 1,692 patients from the Cancer Genome Atlas project for lung adenocarcinoma and squamous cell carcinoma, the 2 most common subtypes of lung cancer. Using race as the independent variable, we tested how different formats of input data affect our variables of interest, which are the AJCC tumor, node, metastasis, and stage classification variables. We manually generated 6 different data frames for testing how stratified sampling, dropping in race attributes, and synthetically masking data impact the imputed values. Then we imputed the missing values using the remasker imputation method, which uses a mask autoencoding framework. So to explain this in simple terms, the algorithm basically masks its own additional values at random and tries to kind of reverse engineer to calculate the missing values upon optimizing and training the autoencoder. We decide to calculate the correlation between variables and also evaluate individual values across 5 metrics, which are imputation accuracy, overestimation, underestimation, sensitivity, and specificity. By evaluating the imputed results on several different layers, we can have a more comprehensive and holistic understanding on what these imputed values actually mean and how it may affect the clinical scene. So upon visualizing the data and calculating the performance metrics, there are a couple of findings I wanted to highlight. First is that the accuracy, sensitivity, and specificity metrics perform the best for white patients, then Black patients, and the worst for Asian patients. We also noticed that the inclusion and exclusion of race attribute did not have a significant impact on imputation performance, which implies that the reason for these disparities in performance is not necessarily because the algorithm recognizes a patient's race and just decides to produce a skewed result, but rather the imbalance of the racial demographics in the data itself is what causes hinder performance for minority groups. Remasker also seemed to consistently overestimate AJCC variables, which may misframe patients as having more severe lung cancer than they actually do, potentially resulting in more aggressive treatments. So unfortunately, it does seem that the imputed values do echo the bias demonstrated in the input datasets, and thus result in worse performance for racial minorities within the dataset. And there was a lot I wanted to explore with this project, but I didn't have time. So I would like to continue this project even after this program and conduct further analysis on different data sets, other underrepresented demographic groups, and also further evaluate these imputed results using machine learning models. We also acknowledge that this research was only done on white, Black, and Asian patients due to the available dataset only having adequate samples of these 3 racial groups. However, this simply highlights the very issue of the underrepresentation of racial minorities embedded in the data we have access to. Data is used everywhere, but the very least we can do as researchers is to be aware of such disparities and being honest about them. And I believe that this type of visual exploratory analysis in the very, if we conduct this in the very results we produce and communicate to our audience, we can highlight and make this problem aware to everyone. Lastly, for acknowledgements, I would like to first thank my mentor for all his guidance and attending the symposium despite his very busy schedule. I would also like to thank Open Bio staff members for making this opportunity happen in the first place and hosting office hours, which I really liked attending. And lastly, I would also like to thank all my friends and families that were with me throughout this very new and also challenging experience as they worked on a project that I love from my house. Thank you.
Awesome. Great job, Tracy. Thank you so much. Up next, we have Valeria Mailing Martinez Chu, who will be presenting on From Ocean Currents to Epidemics, the ENSO Dang Connection in South America. And apologies if I butchered that title, but your 5 minutes starts whenever you're ready.
Thank you. The incidence of dengue fever has seen a dramatic rise in recent decades. This surge has led the World Health Organization to estimate that over half the world's population is now at risk of dengue infection. Dengue has become endemic in 100 countries, with South America identified as one of the most highly infected regions. Dengue and illnesses like Zika thrive in tropical climates due to their classification as arboviruses, transmitted by vectors such as mosquitoes, ticks, and sandflies. These viruses can cause a range of illnesses, from mild fevers to severe and mortal conditions. Typically, the virus replicates in the vector's digestive system after ingesting infected blood, then infects other hosts, usually birds or mammals, with humans often being incidental hosts. However, there are exceptions to this general pattern. The Aedes aegypti mosquito, originating in Africa, relies on human blood and thrives in stagnant water. Its proliferation is influenced by temperature, with urbanization and climate change accelerating its global spread over the past 50 years. These mosquitoes' extended infectious period significantly contributes to the global burden of dengue virus, the most prevalent arboviral disease. By recognizing the complex relationship between dengue proliferation and climate, we identified a pressing need to understand the influence of El Niño Southern Oscillation phenomenon, abbreviated as ENSO, one of the most significant modifiers of temperature in the region and the world, on dengue epidemiology in South American countries. The continent's rich diversity in seasonal changes and climate variability further underscores this necessity. This research aimed to understand the dynamics of dengue in South America, with the objective of sharing its findings to benefit other regions similarly affected around the world. By examining the association between the ENSO and the incidence of dengue fever outbreaks across South American countries, we hope to contribute to improved disease control and forecasting methods. Dengue fever case data from 1990 to 2024 was obtained from the PLISA database from the Pan American Health Organization and World Health Organization, and population data from World Bank reports. To analyze and compare data across countries, a standardized formula was used to derive the dengue incidence rates. Scatter plots with linear trend lines identified peaks in dengue incidence during neutral and ENSO years and observed overall trends. Our findings revealed that the relationship between ENSO phases and dengue incidence varies geographically. While no clear correlation is observed in Venezuela and Suriname for either ENSO phases, a moderate positive trend is found between the La Niña phase and increased dengue incidence in Atlantic coastal nations such as French Guiana and Brazil, while the Niño phase is associated with significant rises in dengue cases across most South American countries. During El Niño phases, the warming of the Central and Eastern Pacific can increase wind shear in the Atlantic, suppressing hurricane formation and intensity. Conversely, La Niña events, characterized by cooler Pacific sea surface temperatures, often correlate with enhanced hurricane activity in the Atlantic due to reduced wind shear. This can lead to increased rainfall and flooding in some regions, while causing droughts in others. La Niña generally brings increased rainfall to Atlantic countries and droughts to Pacific countries, whereas El Niño has the opposite effect. This dynamic suggests that countries with an Atlantic coastline, like French Guiana, experience higher dengue incidence during La Niña years. This highlights the need for nation-specific research to understand these complex dynamics better. Despite methodological limitations, including missing data for Venezuela in 2024 and the absence of advanced computational techniques, our analysis across all South American nations enhances the understanding of dengue dynamics and elucidates the impacts of the usually overlooked La Niña phase on dengue incidence in these countries. Future studies should consider South America's geographic and climate variability and explore societal and economic factors influencing dengue. With the warming climate, it's crucial to predict its impact on dengue and prepare accordingly. History, such as the PHHO initiatives in the 1950s, shows that reducing dengue is possible. This required tailored vector control measures like mosquito breeding site elimination and stronger community engagement for prevention. Thank you.
Awesome. Great job, Valeria. Thank you so much. Okay, and up next we have Yashish Leda, who will be presenting on AI-powered drug discovery of CDK20 inhibitors using AlphaFold 3. Yash, your 5 minutes starts whenever you're ready.
Hello everyone, my name is Yash Ladha and I'll be presenting my research project titled AI-powered drug discovery of CDK20 inhibitors using AlphaFold 3. With the advent of modern cell biology, targeted cancer therapy has become dominant in novel drug development. One of the main methods of targeted cancer therapy includes small molecule inhibitors, which bind to the pockets of target cancer proteins and inhibit their function. To design potential inhibitors, an accurate 3D structure of the protein is necessary. AlphaFold was a huge breakthrough back in 2020 from Google's DeepMind team for predicting protein structures for the entire human genome. Recently, AlphaFold 3 was published with a new ability to incorporate cofactors. Cofactors are non-protein chemical compounds or metallic ions required for an enzyme's role as a catalyst, and they can greatly affect the predictive structure of a protein. To assess the future impact of AlphaFold3 on drug discovery efforts, we decided to explore using AlphaFold3 for the inhibitor design of a cancer protein called CDK20. CDK20, a cyclin-dependent kinase protein, is widely expressed in human tissues and overexpressed in various cancers. It promotes cell cycle progression, oncogenic signaling, and immunosuppression, making it a promising target for cancer therapy. Despite significant success with inhibitors against other CDK family members, there are currently only a few reported CDK20 inhibitors. The absence of its 3D structure could be one of the causes. Previous work modeling CDK20 used AlphaFold 2 to discover potential inhibitors. This work faced challenges due to low confidence predictions near the ATP binding site. We hypothesized that using the newer AlphaFold 3 to predict the structure of CDK20 with ATP bound in the binding site could lead to a more accurate model for drug discovery. To test our hypothesis, we generated two structures of CDK20 using AlphaFold 3 on the publicly available web server. We compared the AlphaFold 3's predicted structures of CDK20 with and without ATP in order to determine if there were any significant differences after the inclusion of ATP. We discovered that in the structure with ATP, there was a significant change in the position of the coils and the alpha helices of the C-terminal region below the ATP pocket, as shown in Figure 2a. In addition, in both alpha-4-3 structures, the residue arginine 305 on the C-terminal did not block the ATP binding site, unlike in the alpha-4-2 structure, as shown in Figure 2b. Next, we wanted to assess if the noticeable changes in the structures due to using alpha-4-3 and optionally including ATP could affect the discovery of novel inhibitors. To evaluate this, we used unimal docking, a program that positions small molecules within the ATP binding site. We tested a previously discovered inhibitor based on the AlphaFold 2 structure to see if we obtained a similar orientation in the binding site. The docking results of the structures reveal that including ATP using AlphaFold 3 leads to a slightly different binding orientation. Additionally, one of the rings of the inhibitors in CDK20 with ATP was rotated, whereas in CDK20 without ATP, the entire molecule was oriented in one plane, as shown in figures 3a and b. Lastly, to verify that the change binding orientation could affect the scoring of the inhibitor molecule during drug discovery efforts, we used a machine learning tool to predict the binding affinity or change in free energy after the molecule binds to CDK20. Binding affinity refers to the strength of interaction between molecules, particularly proteins and ligands. As shown in Figure 4, the predicted binding affinity suggests that the inhibitor is predicted to exhibit a stronger binding to CDK20 in the absence of ADP compared to the binding observed in the structure modeled with ATP. Because of the induced fit due to the presence of ADP during the AlphaFold 3 modeling process, the AlphaFold 3 structure of CDK20 led to a slightly different docking force and binding affinity. The results of the study are helpful for ongoing and future research in understanding and designing drugs for cancer targets with binding pockets, which could be influenced by cofactors or other small molecules. In our work, we observed a noticeable shift in the binding force and binding affinity of our designed CDK20 inhibitor, suggesting that new tools such as AlphaFold3 can jointly model protein structures with small molecules. This can have significant downstream effects on drug discovery and optimization. To finish this work, further analysis with more substrates and other cancer targets is necessary for understanding the future role of alpha-4-3 in drug discovery. I would like to express my gratitude to my mentor Azam for guiding me in my research project. Additionally, I would like to thank the Harvard Open Bio staff for organizing this amazing summer research program. Thank you for your time, and I hope you have a good day.
Thank you so much, Yash. Great job. All right, and last but certainly not least, we have Sarah Xoi, who will be presenting on heart failure prediction using ensemble learning and explainable AI. Sarah, whenever you're ready, your 5 minutes starts.
Thank you so much. Can you hear me?
Yes.
Thank you. Hi, everyone. My name is Sarah Aksoy, and my mentor's name is Ritvik Takar, and he is today here with me. Today, I'll be presenting our research on predicting heart failure using ensemble learning and explainable AI. So heart failure is, as you know, a significant health issue, and accurate prediction models are crucial for improving patient outcomes. In this research, we use explainable AI, which refers to techniques and methods that make the predictions of machine learning models understandable to humans to provide transparency and insights into our prediction models' decisions, helping to build trust and facilitate better clinical decision making. So in the introduction section, we discussed machine learning models we utilized in this study, explainable AI, and related work in this context. We found that combining SHAP and explainable AI technique with ensemble learning is a novel approach, offering a unique perspective on model interpretability and robustness. Moving on to the methodology, we used a dataset source from Kaggle, which includes 11 features ranging from demographic information like age and sex to clinical features such as cholesterol, fasting blood sugar, and resting ECG. This dataset underwent pre-processing where categorical features were encoded, increasing the total number of features to 20. The dataset was then split in training and testing sets with an 80-20 split. We used various machine learning classifiers such as support vector machines and decision trees, but our proposed model is a voting classifier. This ensemble model combines predictions from the listed individual classifiers, excluding the Begin classifier, to enhance performance. We selected the best hyperparameters for each model using grid search CV and assessed their stability with tenfold cross-validation. In the results section, Figure 1 shows that the voting classifier achieved the best overall performance, demonstrating high accuracy and precision, while the decision tree model had the lowest performance. Figure 2's confusion matrices indicate that the voting classifier made the fewest misclassifications, underscoring its reliability. The SHAP analysis is the most insightful part of our study, providing a clear understanding of how each feature influences the model's predictions. In Figure 3, the SHAP summary plot ranks features based on their impact, with cholesterol levels, age, blood pressure, and the presence of diabetes being among the most influential. Interestingly, the analysis revealed that the lower cholesterol levels are associated with a higher risk of heart failure, which is a finding that challenges conventional knowledge. Age is another critical factor. As expected, the risk increases with advancing age, and high blood pressure also significantly contributes to the risk, highlighting its role as a key predictor. The SHAP force plots further break down how specific future values influence each prediction, offering detailed case-by-case explanations. This is particularly useful in clinical settings where understanding the reasoning behind a prediction is as important as the prediction itself. For instance, in Figure 4, the pink features push the prediction probability toward class 1, indicating higher risk, while the blue features push it toward class 0, indicating lower risk. In conclusion, our study demonstrates that the voting classifier is the most effective model for predicting heart failure, offering the highest accuracy and stability. The SHAP analysis provided critical insights into the factors influencing predictions, making the model's decision process transparent. Moving forward, we plan to refine our models, explore additional features, and collect more data to verify our findings, such as the cholesterol level finding that challenge conventional knowledge. By using a larger and more representative dataset, we aim to confirm these findings and further improve prediction accuracy. This approach will enhance model performance and build trust among healthcare professionals by providing clear and interpretable results. Thank you for your attention. I also want to thank my mentor for his support and guidance throughout this study, and the Open Bio team for giving us this wonderfully valuable opportunity to be researchers. If you need more information about our study, feel free to send me a message and I'd be able to share it with you. Thank you.
Thank you so much, Sarah. Great job. And that is all of our presentations for today. You all did such an amazing job, and I hope you're all so, so proud of yourselves and all that you've achieved in this program. It's so incredible that before you even get to college, you're able to do such high-level research, and we're just so proud of each and every one of you. So for the time being, I think we're gonna wait for some of the other rooms to wrap up. Feel free to head back out to the main room. And then we will have some of our closing remarks there. But yeah, great job to everyone. I hope you're all feeling relieved and satisfied, and I will see all of you out there.
Thank you so much. See you.
Thank you.
See you.
You.
Bye.